Okay, so by now, everyone should have a model which would serve as their solar study. Now, we are going to start the production of the actual building. And if we take a look here at the class mirror board, we see where we have the design and working drawings as images here, right? And you can take a look on this whenever you get the chance. These have pretty much all of the measurements and details you need in order to create a model of this building. Now, of course, originally, looking at the presentation showing the architectural design process compared to the process of creating a BIM model, we are basically at this stage where we created a massing model. Now, in a design environment, you perhaps would not have a complete set of drawings already complete, because you would be in the process of actually creating those drawings from your massing model. However, in our situation, we actually have already our construction drawings, and instead what we're doing is kind of re-engineering that process, and hence learning about BIM and REVIT during that process. So that is where what we're doing now will deviate from maybe what you would have done if you were working on your own designs from scratch. So if we take a look at the board, we can see that we have pretty much all the drawings that we need to reproduce this here. Now, if we were in a design environment, then maybe we would have utilized some of these walls to be actual walls. Perhaps some of us would delete these walls, or maybe we would start to move them around a little. It is up to you when you are in the design environment. However, we are not designing in our project. What we're doing is recreating something from drawings. So hence, we will not need to use these walls and floors that were generated from our massing model. So the first thing that we're actually going to need to do is to actually delete these walls that we used to create our solar study before, right? So we're going to do that now. Now, what I'm going to do actually is to just select pretty much everything, and I'll use the filter command. And what this does is it allows me to select all walls. So I'm going to select only walls. There we go. I'm going to hit delete. Now all my walls are gone, and then I can delete the floors and the roof. All right. Now remember, we still actually have our massing model. If we go over to massing on site and then go over to show mass, we can see that we have our massing model here. Now remember, a massing model is really just a kind of ghosted figure that we use to help us design. But in this case, we are not designing, so we don't really need it. But we had to learn how to use it, hence why we have the massing model here. Now we don't need to worry about it. It's not an actual object, so it's actually not going to affect our process of recreating this model, right? So I'm going to just switch that back off. However, we do have the site outline here. So if I go to my site plan, we'll see that we do have our site ready to go. We also had set up our project north and our true north. All right, so we have those settings good to go now. All right, And as you can remember, the reason we had Project North and True North is because when using Project North, our drawing would be more aligned with the sheet that allows walls and grid lines and columns to be easily drawn. And we have our True North, which aligns to the actual north, to the actual true north being directly upwards. Now, if we look on our board, we can see here that we have our site plan, and this is what we used to orient our drawing so we could generate our solar study. All right. Now, in terms of how we will be tackling the creation of our BIM model, there are a couple guides that you might find here on the digital board. So for example, most 3D BIM models can be created by a simple 6-step process, right? The first thing you need to do is to set up your project. You need to have the name, the information, the location, and all these things set up. Things pertaining to the site, your True North, Project North, all of those project things need to be set up. Next, you need to set up things to guide the model production. And when I say things to guide, typically that is your grids and your levels, but it could be other things. Suppose there are reference objects. For example, if there is a contextual object, maybe a neighboring building or some kind of contextual structure that helps to position your building. Anything that provides a guide to how your building will be modeled, that's what you want to put in first. Next, you want to try to focus on building your outer shell, pretty much your outer walls, major walls. You don't want to start putting in tiny elements like windows and doors at this early stage. You really want to get the shell or the basic footprint of your building laid out. And then you want to create your site. So even before you start to add details to your building, it is a good point at this next step to start to create your terrain. You have things like walkways and pathways. Sometimes you have things that are based on the shape of the site. So all those things should be put in and lined up with the shell of your building. And then we will start to add details. So things like windows and doors and furniture and all of these things would be a good point to start adding them in after you ensure that your building shell is good to go and the site is good to go. Now, when all of these are done, then we can start to generate outputs from the BIM model. And notice I use the word generate because most of the things that you'll produce in are going to be generated from the model. You would generate floor plans, maybe sections, even renderings. You might extract details. All of these things are things that you want to be able to just generate from the building because you've invested the time in creating the building. Now, there are some other things to consider for each of these levels, but in a nutshell, those are the simple steps that we would take. Now, on this board also is some breakdowns as to what should be considered for each level. But as it is now, we're just going to jump in now to deal with pretty much step 2, which is to get the things that guide our models creation in place. Now, we're going to be needing to constantly take a look at our plan or our floor plans, because the first thing we want to create is the building model. Now, you might notice the first thing we want to be looking at is how the grids are laid out and the distances between these grids. So you can kind of see these distances here, and you can see these grid lines here. Here they are here in these locations. Now, these grid lines, notice that you can also see them on different parts of the building. So for example, if you look on the upper floor, you will also see them there. And if you look on the site plan, you will see them as well. Now, the idea is whether you are designing a building from concept drawings, or you're simply creating a building from detailed drawings, which is what we're doing now, the first thing you want to do is identify your grids and your levels. So we see a couple grids here. We have some dimensions for it, and next we want to look at our levels. So let's take a look at the section view. We can see the section view here, and we can have an idea of where our ground level is and an idea of our upper level. Here is a detail section, so we can see the ground, we can see the upper level, and we can see other little details such as the footing and so forth. For right now, we just want to focus on the major levels of the building. So we can see from here that our ground floor here, then we have our upper floor here, and here is that measurement, and then we have our roof, which is here, and we want to just establish these levels and these grids as a primary way forward. All right, so with that said, now you can, for example, in order to have these side by side, you could, for example, also place these drawings in your REVIT model. So for example, let's say that on our ground level, which is, we actually have some plans here. Here we go. So this would be our ground level. We can actually download this. So I'm going to hit the download here. And we can actually drag that into our model here. Now, what I'm going to do actually is I'm going to drag it into our level 1. So we're going to go on to level 1. We're going to ensure to switch to our project north. And then I will drag this drawing in here. Now, once the drawing is here, we can now scale this drawing. So let's scale it. So I'm just going to kind of estimate the rough size, which is about that. And then I'm going to use a reference line. So in this case, I'm going to use a model line. So I'm going to go to annotate, and I'll grab not a model line, but a detail line. And I'm going to look for a large measurement that I can use to scale this drawing. So the best measurement I see here, let's use one of these grid lines here. All right, so here is one. So we could actually use this measurement. So what I'll do is I'll draw a line from here. And the idea is that from this point here to this point here, should be 8,696 millimeters. So 8,696. I believe we're in meters, so should be 8 point. Or actually, I can just put millimeters at the end. All right, there we go. So what this is telling me is that this line from here to here really needs to be reduced to this point, which is here, right? So I can use that to actually scale this drawing. So I'm going to make sure I click on the drawing. Then I'm going to go to my scale, and I'm going to grab this point here. Then when I can estimate this point here like that, and I grab that, and then I'm going to reduce it to this point here. All right, there we go. So now it should be scaled, and I can actually test that by using my dimension tool, which is up here, and I can just use the tab key to go from there to there, and you can see that, well, this kind of rounds it up. What I can do is I can go to manage and go to units, and I can actually switch my units from meters to millimeters, and I don't need that at 2 decimal places. Maybe just 1 decimal place is fine, or actually none is good enough. All right, there we go. So I can see here that my actual length is about the same as this. Now, important point to note here. What we'll be doing is translating these measurements and not tracing them. So for example, even though I have this dimensioned scale, if I, for example, try to measure something else. So for example, I could draw a line from, so I'm going to draw a line using here, and you don't need to follow with this. This is just an example here. If I draw a line from here all the way to this point here, it should be equal to 18,346 millimeters, right? So if I take a dimension line here, let me just pull that up, you can see that it's actually measuring 18,400, even though I traced, well, as best as my eye could recognize between these two lines. Now, this is why it's very important that we don't trace, because clearly you can see that this is different from that. Now, in order to get the exact accurate measurements, you will be needing to actually input these values directly into your drawing rather than what I would call eyeballing it, rather than tracing these lines, because these lines will actually not get you the correct measurements. As you can clearly see here, I traced the lines and it's kind of close but not close enough. Now what's going to happen if you trace the lines, when we get to doing things like the stairs, which you can see here, and we start to deal with things like radius, these radius are going to be way off, because a lot of these lines, a lot of these dimensions, the inaccuracy of them will add up over time. And as you build upon inaccurate data, the resultant data will be even more inaccurate. So what is actually recommended, and in order for you to get the maximum marks for accuracy, is to input these values, but you can use the scale drawing as a kind of visual guide, not to actually trace and draw your drawings, or else you will end up with this situation. All right, so that was just an important point to note. Now, once we have our drawing scale, it will serve as a great reference as we go forward. Now, the next thing that we want to highlight is also our height. So if we look at our drawing here, which this section is really a design drawing section compared to this section here, which is really a construction drawing section. It has more details and all of that stuff, whereas this one is more of a presentation. However, the heights remain the same nevertheless. So what I'm going to do is I'm going to use these heights to determine the level of my building. All right. All right. So now that we have that done, what I will do is, in my case, is even though I have this drawing here, I am going to actually use the board to measure to put in the measurements for my drawings. So on this side, I'll have my drawing, and over here, I will have my dimensions. Now, some of you might prefer to actually have your drawing on the board. I find it a little bit slow in terms of workflow, because I will be having to look here and then pan over here and then go back over here, which can be very tricky. The other option is if you choose to put your drawing below, and even though you might not trace, but you still want to have your drawing as a guide below the lines, I find that the drawing gets the lines confused, because all of these black lines kind of confuse the drawing line. So, you know, everybody has their own way of producing drawings, but in this case, where we're going to be pretty much digitizing this drawing, I find that a side-by-side approach with an occasional check-in of a scale drawing is the best solution. As I can quickly kind of hop between drawings to find measurements. So that's another recommendation. All right, now to get things started, let us look at the levels we currently have. Now, a good way to look at our levels you can't see levels from a top view. So the best way to look at your levels is either in 3D view if you have REVIT 2019 and up, or you can look in an elevation view. So if I choose any elevation view at random, you will see that I have my levels here. Now, instead of dragging my drawing into this view here, what I'm actually going to do is I'm just going to look at what we have here for my section. And so I see here where my level 0, between my level 0 and my upper floor is 4,700. So I'm actually going to put this at 4,700 by just clicking. Editing that, and then I actually need to create another view that will represent I labeled it the roof, parapet, wall top here. Now, to create another level, what you want to do is head over to the architecture tab, which you find here, and then you will see the level symbol, which is here. Now, your level symbol might look a little different depending on how wide your REVIT drawing file is. So for example, you might notice that if I widen my REVIT here, you will now see my drawing, my level symbol like that, and it's much bigger. So keep a note on that. All right, it depends on the size of your REVIT drawing. Okay, so now because I'm going for a side-by-side approach, I'm going to be having my REVIT back like this, and I'll have my drawings here. All right, so I'm going to create another level by pressing the create level, which is on the architecture here, and I'm going to create that level. I see it here at 9,500, which really measures from the ground floor up. So I'm going to just randomly place my level here, and Now notice when I just place my level here, a couple things happened. Let me press escape. Now you will notice that you got a new level 3, which corresponds to the level 3 here. You also got a new level 3 ceiling plans as well. And also notice that the color of the level symbol here is blue. Right? Now all these points are important. Now automatically when you create a level like this, it will create new views. Now in some cases, for example in this case, though I created a level called level 3, I don't necessarily want to have a floor plan level called level 3. I'm just going to have my ground floor, which is level 1, and my upper floor, which is level 2. Now, if I have a level 3, that will pretty much be a roof plan. But I have my site plan, which is already looking at the roof of my building. So there is really no need for me to create a level 3. Now, you can create a level 3 if you want. It's not going to affect anything with your drawing. But just a point to note that every time you create a new level, it will create a new drawing. And in some cases, that might be a bad thing. In the case of the roof plan, it may not be a particularly bad thing. But for example, let's say that I was going to have a kind of a middle level, like for maybe a stage or some intermediate floor. So maybe in my drawing, let's say that there is a ramp and my ramp kind of went up and I had another level here. So ideally in Revit, I would want to create another level to represent that new level. However, notice that if I had created a new level here like this, it will be called level floor 4 automatically. Now, the thing about that is it's great that I have a level here, but then it also created a level floor here. Now, in this case, it's a bad thing because I don't need a new level because my level 1 is my floor plan. So in creating a new level, I'm essentially creating the same floor plan over again because they're essentially going to show the same thing. In addition to that, it's also creating a ceiling plan for that level as well. And as you know, a ceiling plan is where if you're a person here, then you're looking up at the ceiling, and that's a new plan. Now, of course, there's no reason to generate a ceiling plan under my ground upper slab here. It's pointless. I really just need a ceiling plan here, which would be for my level 2. And maybe a ceiling plan would be for my level 3 if I so choose, right? So in this particular example, a level floor plan, which is here, is a bad thing. So I'm raising this point to say that not every time you want to be creating a corresponding level with an actual level in the drawing. In some cases, you just need a level so that you can use as a reference point and no plan generated with that level. Now, in the case of my upper floor, it is not so bad because I may need a plan that looks down like this, which would be attached to this level here. And I may need a ceiling plan that looks up like this, which would be attached to this level here. So that's kind of okay. But definitely, if I was creating an intermediate level, I would not need another floor plan and another ceiling plan, which is a bad thing. So that's just reiterating that point. So I'm going to just undo that, as I was just doing this just to illustrate the point of levels that are created here. Now, as I create this level, I'm going to align it properly. So I'm going to just drag it across here. You notice you get this little dash line that pops up, and this tells you that it's now in line with the other levels. And notice you get a little lock here, which means that now when you try to move one, all three of these will move in tandem. Now I also want to carry the other side of this level all the way to the end over here. It doesn't necessarily matter at this point in the drawing. It might change a little bit, but that's okay. And notice that I drag it till it's locked there, so now these are both locked. This little checkbox here that is here really just represents if you want to have another level symbol at the end or not. Now additionally, you might also notice that you see a 3D icon here, and what this is simply saying is when this icon is on and you manipulate this line, you will see this line change or be visible in other views. So for example, if I'm in the east view and I change the length of this level line, then if it's, I can maybe view it in the west view in the background because the 3D option is on. But if it is changed to 2D, then it will only be visible in that view. This may come up later when we start to generate views, so for right now we don't really have to worry about it that much. All right, now one thing that we do have to worry about, if you have been following along and you have created another third level here, then you might want to set this to 9,500. But before we go any further, I want to highlight something that you may notice. Now, if you go over to your 3D view, which is located there, then in that 3D view, if you did your solar study before, you would see the solar study still be represented there. We can actually remove this for the time being. So I'm going to turn it off by going here and turn off the sun path. Now, I want you to notice something. So we know that this green line here is our site that we traced over as a model line, so we can see it in the 3D view. But I want to point your attention to this level here, and then this level here, and then we created this level, which is here. So that is going to be interesting, and if you are following along, then you might end up with this same effect. So if I kind of zoom out here, you may wonder, you know, why is that third level that we created so out of whack with the other levels? I can zoom in here. You can see that that is the third level we created, and here are the original two levels. Now, if I align it in an elevation view, you can see that, well, obviously the heights are fine, but in a 3D view, they are aligned differently. And all these alignments is basically, it's just basically showing us, like, think of it as horizontal slices through our model that determines the height at which elements are. So for example, if I should turn this like that, you can see how the different levels are applied, where you can see, you know, between here and here, and then you can see the difference between here and here. So as it relates to elevations, you know, the levels are correct, but definitely something is off with it being in alignment like this. Now, the reason for this is because we have set up our model, and remember, our model is not perfectly aligned to the north, so we had to create a true north and a project north. Now that is the same for many projects out there. And if we look back on the site plan here, you'll see what I mean. This is our building here, and as you can see, this, our north, goes directly up like that. So that is our north. Now, of course, we rotated the building that way just so that the building would be more aligned to a grid, you know, so it would be easier to draw. And in doing that, we would have also had to rotate the north this way. Now, because of that, you might notice in REVIT, if I go back to maybe my level 1, you might notice that these icons here, which represent the elevation views, are indeed still aligned to the true north. Because remember, this drawing that I am looking at right now is in Project North, because you can see that it's Project North there, which means that our north is really going that way. All right, so that's our north. And remember, REVIT was originally aligned to, you know, that north. So for example, these icons here represent our elevation. So we have an elevation view like that. We have an elevation view like that, and so forth. Now, this might not be ideal, as, you know, we'll be looking at the building at an angle, but it's definitely ideal to orient the building like this, because it's easier to draw walls and windows and all of that, which is why we had a Project North. Now, this is the reason why you see in your 3D view, which we looked at earlier, why this level line is actually off. Now, to demonstrate this, I'm going to show you a good example. If I should go to my wall tool, all right, and you don't have to follow me here, but just bear with me a little bit. If I go to my wall tool and I should maybe just draw roughly, you know, the shape, basic shape of the building here. This is just a random shape here, right? So let's say that this was a building here, and on this wall tool, I'm going to select all of these walls here, all right? And in my properties, which is located over here, I'm going to set up my base level for the wall, and I'm going to set up my top constraints. So what I'm going to do is I'm going to set my base level to level 1, and I'm going to set my top constraint to level 3. So that means pretty much all these walls will be going all the way up to the 3rd level. Now, if I look at that in 3D, I will see that that is reflected there, no problem, right? So here's my level 1, there's my level 2, and there's my level 3. Now, the interesting thing is, if I try to look at this in a elevation view, so let me go to one of my views here, kind of zoom out, and I don't know if you notice, but if I go to a shaded view, like let's say that view there, you notice that you're actually looking at an elevation view, but at an angle. Let me go to the north elevation, and it's the same thing. If I go to a shaded view, you're really looking at your building at an angle. And the reason for that, I'll go back to my level 1, is because REVIT is still aligned to the true north, because that's just originally how REVIT got opened. So in REVIT's brain, these are the elevations that they're going to use. Now, and these elevation markers here correspond to, here we go, so actually the east elevation here is like that, and you would have, for example, like the west elevation here, which is like that, and so forth. So when you go to the east elevation, for example, you are really looking at your building in that direction, like that, which is going to be at an angle. But ideally, you would want to look at your elevations like that, right? And like that, and like that. Now, the front is a little tricky, but pretty much we're okay with generating elevation like this. As a matter of fact, in our project, we're even going to generate another elevation, which perhaps looks this way, right? So this brings me to how we now have to arrange these little guys here, because if we don't arrange them from now, then we're going to have a situation when we try to look at our building in elevation, it's going to be at an angle. And in our 3D view, you're going to notice that your levels are not going to be lined up. They're going to be like at these awkward angles, which visually can be confusing. So let us try and fix that right now. So what we actually need to do, right? And all this stuff is important because remember, in our steps, and we're here at step 2, we want to be setting up the things to guide the model for production, and the levels, the grids are one of them. So this is why we have to deal with this issue now. So in order to fix that, all we simply need to do is rotate these views. And so, for example, you can clearly see that this is looking that way. So we just need to rotate them so that they look that way. And in order to do that, we're simply going to select them. So what we're going to do is, just to make life easier, I'm going to carry this here, right? And we can kind of use this as a general guide. This is pretty much our axis here. So let's say that we want this elevation here to be looking east. Now we can know our titles for our elevations before we start to align these properly. So here we go. We have east, north, south, and west. And if you look at how this icon is aligned, right? So what you really want to pay attention to is the tip part of the triangle here, right? So if you click on that part there, you will notice in your properties, that's over here. If you scroll down in your properties, we're gonna just carry this down a little more. You will notice that this is really your south elevation, right? So what we want to do is, so this is the elevation that is really facing the south. So I would say the closest elevation to that, because remember that our building is now going to be at an angle. So in essence, this is what you kind of end up with. So north is now that way. So we're, so this is going to be west, and this is going to be east, and south is going to be that way. All right. So that's pretty much how it's aligned now. Now, pretty much everything, the elevations now will kind of be like a, like a southwest elevation and so forth. So we might just label them so that they are in alignment with what we're doing here. So what we're going to do is, based on how this is, this would really be our like a southwest elevation. This would be like a northwest, and this would be like a northeast elevation here. And directly here, we're going to create this new elevation later down in the project. This would be like a direct south elevation here. So we're going to have to rename these elevations as, this face of the building isn't exactly pointing specifically south, or specifically, it isn't exactly facing specifically south or specifically west. It's kind of in between the two. So as to not get confused when we start to generate these views, we would want to name these views appropriately. All right, so in doing so, we're going to click on this little triangle here. And we're going to say that this elevation is really facing southwest. There we go. So we have named this view, and then we're actually going to align it so that it does that. Now, in order to align it, I'm going to leave this on the screen here. But in order to align it, we're going to click on the box. We're going to use our rotate tool, which is located there, right? And we're gonna click and drag this little dot here. We're gonna put it right in the middle. Notice it gets highlighted with a triangle. So when it snaps to the middle, we release it, and then we're gonna grab this point here and rotate it that way until it's perfectly flat. There we go. So now this view here is looking at the southwest elevation directly. And if we should look at that view, which we call southwest, which is this elevation here, let's just hide that note, you can see that we are indeed looking on a flat face of the building, which is here. And if I kind of split these views by dragging out this view here and kind of putting that over there like that. So that is that elevation there, and we can go back to our plan view here. When we highlight this wall, we can see that that is this wall here. When we highlight this wall, we can see that that is that wall there, right? So clearly we have proven that we have now aligned this elevation properly. All right, great. So now we're going to do the same for the other views. All right, so we're going to go back to level 1, and we also need to, along with this, we need to notice that when you click on the little on that little arrow there, you will also see that this blue line is here, and this line represents the clipping plane. Basically anything behind this line. So we are talking about this line here. So anything behind this line will not be seen, and anything in front of this line will indeed be seen, right? So because of that, we want to actually adjust this line so that it is roughly, you know, like right here. So therefore, you can kind of think of this line as it will encompass everything looking that direction. So that elevation is now set up. All right, good stuff. All right, now what we want to do is we want to so now let's fix up the rest of our drawing here. So we had this elevation here, and this elevation is going to be our northwest elevation. If we scroll down, so I've clicked on the little triangle, and if I scroll down here, so it says west, so this is now going to be our northwest elevation, like that. Now notice that I can click apply whenever I make a change here, or once I move my mouse outside of this properties box, it will automatically click apply. So that's a great little feature there. All right, so now I've named it northwest, and I'm going to do the same thing again. I'm going to move this box. I'm going to click on the box first. If I can just get to the box there. Let's move it over more in place like that, and then I am going to choose rotate. I'm going to move this to the center here, and I'm going to click this point here and rotate it till that is completely horizontal, like vertical like that. Let's move it more in the center here. And where is our line? Let's move our line like right there, and that's good enough. All right, we're going to do this one more time real quick. The shortcut for rotate is RO. And of course, we're going to now name this view. If I look back on my compass, you can see that this side is really facing the northeast side, right? So I'm going to click on that little triangle here. And we're going to go down to the name. There we go. And we're going to call that northeast. All right. Now for our last view here, this is going to be the interesting view. What we actually want to do with this view is we want this view to be looking directly this way to show us the south, right? So instead of looking that way, we're going to be looking at the building this way. So this is actually going to be at an angle, which we are going to set up later in the project. Now, for now, what we're going to do is we're still going to have a view looking this way for now, and then we will set up that south only view later in the project. So this view is going to be our southeast view. So that's the last one that we're going to set up for right now. And we will set up that other south one later on in the project. All right, so let's do that now. So we're going to do the same thing. We're going to go to rotate, put that in the center, and just use that to orbit this like that. And you want to make sure that these views are completely flat, or it will throw your drawing off. So we're going to call that south east. There we go. And we're going to move that in place. Perhaps what we'll do is place this one like right here, and let's get the line and put the line here. All right. So now we're all set up with the views, and our view should be looking directly on the building. And those views correspond with these views here. Now would be a good time to save. So what I'm suggesting is that you save this project. All right, so now that we have the project saved, what we're actually going to do now, if we go back to our 3D view, we still have our little dummy object here, but notice that this weird level is still there. So we're actually going to delete that level, and then that message was just telling us that, hey, you tell the wall to go from 0 to level 3. So if you deleted the level 3, this wall will no longer have a reference height to set, but that's okay. Now we're going to actually go back to our, well, let's go to the northeast view. It doesn't really matter what view we go to. We're just going to go to any view, and now we're going to draw back that level. And according to our drawing here, let's go back to that elevation view. Here we go. So it should be 9,500. It's 9,005, so that's great. And we are gonna set this up like before. So we're gonna drag this all the way over here like that. And while we're at it, we're gonna just extend these other views. So we're gonna put that here, we're gonna put that here. We're gonna change that to 3D. Okay, we'll change that later. There we go. All right, we'll leave that on for now. So we'll leave it on 2D for now. Doesn't really matter. Remember, that only affects how the line looks in another view. Let's try and just drag this over to here. There we go. All right, so now let's just drag this one here further down. Okay, there we go. That's not bad. Let's look at another view. That's here. I will want to be doing the same thing. We're going to actually drag this view over here. I keep changing these things. There we go. All right, great. So what I'm actually doing now is just aligning all of these levels so that they completely kind of cover the building. It will help us out later on. So you want to check all of these views. All right, so let's do the same thing for here. There we go. So when you go in all the views, you want to just make sure that they completely cover the building. Now, when you go to your 3D view, you will notice that all your levels are lined up nicely and they properly kind of slice the building. And remember, the step that we are doing now, which is to set up the things to guide the model. These things are important because they can really throw you off if you haven't got these things set up. Now, I'm also going to delete these walls here. You should not have these walls. I just put in some dummy walls just to kind of demonstrate how important aligning these things are to your elevation. So I'm going to just filter this and say select walls only, and I'm going to delete these walls here. Okay, good. So now we have our levels all set up. So let's go ahead and look at our grids. All right, now if we go to the level 1, let's look back at our drawing here. And let's take a look at maybe our floor plan, ground floor, so we can start seeing how these grids are laid up and how these columns are laid up, so we can start to put these in. Now, I think one of the best drawings to maybe get started on is maybe this site plan view, because what happened is that this site plan view will actually show, for example, the distance between the boundary line and the grid line, right? Because remember, we establish our boundary lines from the coordinates, which would have been from the surveyor. So that will ensure that we are 100% accurate. Now, what we want to do is establish our building location based on the boundary line. So this drawing here begins to set that up. Now, we can see how we're going to put these grids on, and we can see the distances between them. So what we're going to do now is to go to grids. Now our grids are located here. Again, my icon is a little squashed because my Revit screen is a little bit smaller than your Revit screen might be. So actually, I'm gonna just kind of drag this over some more so I can get a little more space in Revit. And well, I guess that's as small as my board will go. All right, so we're going to use the grid tool here, and to set this up, we're going to start by drawing our first grid, right? So we're going to start here and kind of go down like this. There we go. Now, right away, I'm just kind of estimating this distance because I can always adjust it later on. Notice that in our grid lines here, on one axis we use A, B, C, D, E, and on another axis we use 1, 2, 3, 4. So for example, if we're referring to this column, we can say the column at grid, 3A or A3. And it will help us to identify things on the drawing. Kind of similar, think about using Excel. Most of us use Excel, and that's how we find where the location of a cell is. So we want to be doing that same thing. Now, also, the other important point to notice is that this drawing is also rotated. So this, because it's a side plan, it is actually at true north. So if I change my drawing to true north, it will look like this. So as a matter of fact, I realized that this grid should actually be here. So let's actually just rotate that. I'll use my rotate tool here, and I will just rotate that at 90 degrees like that. All right, there we go. So what I'm actually putting in now is this grid line here, which would correspond to this grid line here, right? So I just switched to the same rotation just to make sure that I'm not making any mistakes, which was very helpful because it helped me to align the drawing to the sheets that I'm using for dimensions. All right, great. So now we have that. All we need to do now is to establish the measurements, which we see here. So we can start to establish that measurement, which is basically going to be that measurement there. All right. So now notice in REVIT, whenever you click on an object, it usually shows you the distances that is closest to the nearest elements beside that object that you have selected, right? So you can see that it showed me a temporary dimension here, and it's called a temporary dimension because if I deselect, that dimension goes away, which you can see there. If I click it again, it comes back. Now, these temporary dimensions are really great because they have this little icon which is here, and they allow you to turn your temporary dimensions into an actual dimension. So what I'm going to do is, while I have this grid line selected, I'm going to insert the measurement here, which is by just clicking on this temporary dimension here, and I can just type it in, which is 4,735. There we go. So now I know that that's exactly that. Now I can just click on this icon here and turn it into a real dimension. So therefore, when I click off of it, that dimension still remains, which is great. Now, don't worry too much about the size of the dimension because we're not going to be setting up our scaling until further down. All right. And if you look back at our process here, and you can kind of look at this detailed process here, this gives you a good idea as to when to approach certain points in the drawing, so you can always take a look at that as well. Now, okay, let's go back to this drawing that we're going to be using, which is actually this drawing here. No, that's this drawing here, right? Funny enough, this drawing is really the upper floor, but doesn't matter at this point because what we're really getting are the grids. All right, now that the grids are in, what I want to do now is I want to actually label these grids. So when you click on the grids, you're going to click on this little element here, and I'm going to change that to A. There we go. Now I'm going to copy this grid, and of course I can see clearly that when you copy it, what the dimension should be. So I'm going to click on that grid here, and I'm going to use the copy tool, which is here, and I'm just going to copy this down, and it's going to be 5537. There we go, and it automatically named the next grid B. I'm going to delete this dimension here, and what I can actually do is when I click, I can actually use my dimension tool up top, and I can put in my own dimension. So I click here, then click here, then click here, and you can see that I have my dimensions there, and these dimensions coincide with the dimensions here. All right. So again, notice that when I put these dimensions in, I'm actually typing them in. I'm not tracing them. And if I did try to trace it, highly likely I would not get the exact dimensions down to the millimeter. So this is important whenever you're reproducing drawings. All right. In this case, we're reproducing because we are not creating the drawings from scratch. Okay, now we're going to continue to add in some more of these grid lines and reference elements. So I'm going to just go ahead and put these in quickly. So the next one we have, so we have another dimension here. So I'm going to use a shortcut for copy, which is CO. I'm going to copy that down there, and that one should be the same. The next one is going to be 8,698. So I'm going to click that here. And 8,698. All right, there we go. And sometimes I love to like leave my dimensions there so I can kind of track to see how accurate I'm drawing these lines. All right, good stuff. Okay, so now to put in these other dimensions now. Okay. Now this dimension here, which you can see here, is 8,100 from the boundary line. So I'm going to put in that dimension now. So we're going to click on grid lines, and I'm going to just add this in. Now notice I just kind of drop it in as long as it's parallel, and then I worry about changing the dimension lines. Now this dimension is counting 1, 2, 3, 4, so I'm going to change this to 1, and I'm going to turn on dimensions, turn on the symbol at the end here, so that is 1. All right, so that one is 8,100 from the boundary line. So when I click here, I want to change this to 8,100 like that. And I know the distances between them. I may have to look at another drawing here, or I could even look at some of these drawings here. So I was looking at one. Okay, here we go. 1, 2, 3. So notice that in some of these cases, you might have to look on another drawing for some of the dimensions, which is fine. This is why I say it's a good idea to have all the drawings in one location where you can quickly hop between each drawing. So so the next, and because they are labeled, you can easily know which dimension you're talking about. So we did A, B, C, D, E already. So we're going to do 1, 2, 3. So here we go now. So 1, and the next one is 4332 millimeters away. So of course, I can just switch this to work now in Project North, which would make this a little bit more reasonable. Actually, so Project North may not be exactly aligned to this drawing here, but that's fine. Doesn't matter. All right, it's just easier to copy when it is aligned to the lines here, right? So I'm going to copy this here, and all right. Okay. All right, and our next line is 8696. And notice that the grid lines are automatically doing this. They're automatically counting for us. All right, good stuff. Now let us just extend these lines outwards. All right, and Yeah, we do have one more line here, which is, here we go, 86696 again. So we're going to drop that there. Let's put in a dimension line here. There we go. Now we're going to do another one. I'm using the copy tool now and copying this down like that. All right. And that would mark the other end of the building. Now, when we're putting in the we start to put in our walls, we also want to notice the thickness of the walls. Now, some of these drawings have the thickness labeled on them. You will kind of have to search for those dimensions. So let's look at one of these here that has the walls labeled. So in these drawings, you can see that some of them, so for example, here you go. So you can see where this is a 300 millimeter wall that is there. Here we go. So we can see here that most of the walls are actually 200 millimeters. That's right there. So when we start to now put in these major external walls, we can start to consider these things. Now, of course, the other thing to consider is that this drawing is really the upper floor of the building, and this is really the ground floor. So as you can see, most of the ground floor has really 200 millimeter walls that is there. So back to our drawing now. You can kind of see where we have pretty much our drawing coming together. Pretty much the drawing would fall on these grids, and then this section here we will add in at a later time. It should look something like that. All right, so we do have our grids that will guide us to that endeavor. Okay, now before we start to put in our walls, so if we head over to the architecture tab here, and then we'll see the wall tool that is there. Now right away when we click walls, notice that we see here we have a 8-inch generic wall. So here is a bit of a trick with this system. You will have to determine, is your drawing going to be at its root metric with the ability to switch to imperial if you want, or is the drawing at its root going to be imperial, or and you can switch to metric. Now what do I mean by that? Well, if you realize, sometimes when switching between metric and imperial, the dimensions are sometimes average. So for example, we say, oh, is the wall 150 millimeter, or is it a 200 millimeter, or is it a 300 millimeter? And we sometimes say that, okay, so 150 millimeter is the same as a 6-inch wall. But things get a little bit tricky, because if your drawing is in imperial and you have a 6-inch wall, well, when you switch that over to metric, that wall is going to be about 152 millimeters, right? So that will sometimes get things a little bit mixed up, because in reality the program isn't going to assume that 150 millimeters is the same as a 6-inch wall. The program knows that 6 inches is 152 millimeters. So why do I tell you this? Well, right now, when you look at the wall family that's represented here, this family that you're using is actually based in imperial. So it says 8-inch. Now, you could use this 8-inch wall, and your assumption is that, well, 8-inch is the same as 200 millimeters, so that's fine. And there's really nothing wrong with that. However, when you go into your drawings and you start to draw actual dimensions on those walls, and you switch those dimensions to millimeters, you're going to start getting 152 millimeters. Now, in some cases that doesn't matter, but it's important for you to note. So just a quick demonstration of that. So for example, if I head over to the architecture tab and I choose wall, and I see here that, okay, so I have a basic generic wall of 8 inches. So we say, okay, 8 inches is the same as 200 millimeters. So for example, if I should draw that wall, let's draw that wall somewhere out here like that. Let's zoom in now. And what I will do is I'll use my dimension tool, and I'll use the tab key to kind of tab into this wall here to this wall here. Then you notice that your dimension is really 203 millimeters, even though the wall is a 8-inch wall. Now, important point to note, this is millimeters because you have changed your units under manage to millimeters. However, the families that Revit is using, right? All of the content that's loaded into Revit by default will actually be imperial, right? And we don't need to necessarily mess with this. It's just important to know that the root of all the families is really an imperial system. It's just that you are displaying metric units. So in some cases, you might want to have a drawing where you choose a wall and the wall says that it is 200 millimeters, and hence it is actually 200 millimeters that is loaded in, and not 203, right? To achieve that, you would have to actually go into your project settings, not your project settings, your options, and under file locations, you will have to tell Revit, under places, you will have to tell Revit to use metric for its families instead of imperial. As you can see now, Revit under the hood is really using imperial units. So your project is set to metric, so it's displaying everything in metric, but the source of your content, as in the names of your content, it's really imperial. And it's about the same. So whenever you choose an 8-inch wall, you won't be getting a 200 millimeter exact wall. You'll be getting a 8-inch, which is really 203 millimeters, and so forth. Now, for the purpose of this project, we don't need to change this. This is actually the default feature in Revit, but it's just important to know so you understand what you're really using here. So I'm not going to actually change these options. I'm just showing you, if you wanted to, for example, when you put in a door, a window, a wall, and you wanted those doors, windows, wall to be labeled as metric, actual metric, rather than imperial, That's where you would go to change those settings. For now, it's just important to know that, we'll use an 8-inch wall to represent a 200 millimeter wall, and that's what we will do for now. Now for walls, that's just how, because the default is really imperial, so the naming convention of it is going to be imperial. However, when we start to insert doors and windows, we are actually going to be inserting we can, if we want to, we can insert the metric versions of those. Unfortunately, we can't choose the metric versions of these types of families. These families are called system families, and things like walls are loaded in based on the default template that Revit starts off with. But anyway, that doesn't really affect us. What we want to do now is to start putting in our major walls. So based on our drawings here, we're going to start to align these walls. Let's go back to our drawing over here. And we can kind of see how these walls are laid up. And pretty much on the ground floor, these walls are all 200 millimeters, which we will pretty much use as 8-inch walls. All right. Now, these are also aligned to the, some of these walls are aligned to the grid lines at centers, and some are not. So let's use this drawing here to kind of get an idea. So we see the wall on A is aligned to the center. So I'm going to take the 8-inch, which is 200 millimeter wall. Now I'm going to work with the location line at the center, and then I'm going to just draw this wall in on A. All right, so that's our first wall in, and then we're going to add in these other walls that are here. Now, important point to note, for example, the walls on the upper floor, so for example, on 4 here, which is really representing here, it's really an overhang. So on the floor below it, this wall actually comes in a bit, and we can actually see that on the plan. However, we do have the dimensions for this wall here, so we know that this wall here is this distance from the number 3 grid line that is there. So there we go, and we will put in that wall. Now most of these walls that we're adding in are really just to kind of guide us as we go along. So the center of this wall here is 7977. That's the distance away, so we're going to use from here to the center here. There we go. And if we click on this, we can change this to 7977. All right, so that's pretty much the ground floor. Main walls. Okay, so that wall is there. Then we need to now add in this outer wall, which is here. All right, so that wall, which is here, and we can see that it is that distance away from grid line 2. So what I'm gonna do, you might draw this different ways. I like to copy my walls and just drop them in the general location and then try and tie my dimensions together. So I use temporary dimensions a lot. So this is my wall 1 here with this is my grid line 1 here, and it should be 2 4 3 1. There we go. So, and notice that when I'm drawing my walls, they're like intersecting all over the place. It doesn't matter. I'm going to clean that up as we go along. So this wall that I have here is really that wall there that I'm putting in. All right. And now for wall and line D, which is here, which is this wall here, I'm going to just go to wall, and I'm going to just add that wall in. There we go. And then what I'm going to do is use the modify and use my trim extends to square these off. All right, great. So now we pretty much have the base of the ground floor. So pretty much that is equal to that. All right. Now, what we're going to continue to do is to continue to add in these main walls here. And next, we also want to start to add in some of these columns as well. Now, so if we look at the detail here, and we see that this detail here is really, let me see, that's detail 3. So that's showing this I-beam here along with this concrete column, which are all the other concrete columns. And we see that that reinforced concrete column is 800 by 400 millimeters. So that would be these columns represented here. And let's look at that on the drawings. So all of these columns here. So to get that column in, what we'd do is head over to our architecture tab, and we would go over to columns, and we would actually use we just click the columns icon there, and let's go back architecture, and we'll use architectural column. There we go. Now, of course, it's gonna show this in Imperial, but what we're going to do is we're actually going to go to edit type. We're going to duplicate this column and create our own version. So we're going to call this 800 millimeters by 400 millimeters. All right. Concrete column. There we go. So we have created our own family, and we actually need to make it 800 by 600. So we're going to change the width. So we're going to have 800. Well, let's have it at 400, and the depth at 800. There we go. And we're going to choose OK. All right. And that is now our column. I'm just clicking to place it, and then I can always move it into place. Now, pretty much I can just align these columns based on the drawing that we see here. Here we go. So remember, this is the lower floor. So I can see clearly that 3 and B has a column. So that would be 3 and B here. Here we go. Now we need to set the heights for these columns, but we're just gonna drop them in place first before we start to set these heights up. All right. And what we can do to make this a bit easier to understand is I will just add a vertical version of this plan here, as you know, just to allow our allow us to be better able to kind of align ourselves with what we're seeing here, right? So I'm actually gonna do like that, and I'll just copy this. There we go. And I will leave this on the board here. So now we're able to kind of be more in touch with what's happening on the drawing here. All right, great. So we can start to place most of our column work in. All right, so here, and we're gonna copy this here, and we're gonna do a copy again. CO is a shortcut, and we're gonna do copy multiple. So this will help us out a tad. There we go. I'm gonna drop one there, and we're also gonna drop one on line 2 here, and here, and here. All right, so these would make some great kind of reference points. Now remember, this is the upper floor, this is the lower floor, so this is what we're really looking at this point here. All right, so this area here we're looking on is basically this area here. Well, this is the upper floor actually. So what I should really do is compare that to the lower floor. So there we go. So this area here is the same as that area there. Now, what is a good idea whenever you're producing these kinds of digital recreations is it's a good idea to leave reference measurements around so that you know that you're on the right track. So for example, I may choose to maybe add in a dimension between here and here, and maybe and some other reference dimensions. Now the idea for doing this is you can easily kind of keep track of where you are on when you're comparing to the drawings here, so you can know that these two are linked, and when you go later in the drawing you might end up accidentally moving things around. So having some permanent dimensions there, which it's really temporary because you're intended to delete it, but it's just to kind of know that you are on the right track. All right, so now what we're going to do is to continue. Okay, so if we look at what we're doing in a three-dimensional view here, we can kind of see how these elements are now going in. Now next we want to do is to kind of start setting up our heights. So based on our drawings here, there we go. So you know, the ground floor, we want to select these walls here and set the top constraint to be the level 2, and most of these columns will go all the way up to the top, so we want to set these columns and set the top constraint to level 4. There we go. All right, so that is our model coming into play. Now what we want to do is to continue to add in the rest of these walls. Now, pretty much once you have added in most of your walls, this is what your model should start to look like. You should have most of the outer walls in and have most of the major structures in, and you can kind of see the building starting to take shape. Now, most of the internal walls, we don't have to necessarily add them in just yet, but we want to try to put in as much of the major walls as possible, right? And what we'll do is continue to add to this as we go further with the production of this BIM model. Now, as you add in the upper walls, what you want to do is be sure to use your constraints. So you want to be setting your base constraint to, for example, your level 2 and your top constraint to your level 3, and pretty much just work within those two levels to get the walls in. Now, in terms of the actual heights, if you notice back in our drawings, you might notice that some of these walls are short and some are tall, but we're not really concerned with that just yet. We're basically just going to be operating off of these three levels. So we want all our walls to go in at these levels, and as we develop the model, we will start to add additional levels so we can reference all of these other heights that the model has to offer. Okay, so continue to work on this and try to complete this stage and start to go into part 3, which is creating the outer shell and walls. This is where we are currently going to focus our time on to have complete.